Let's talk about electronegativity, another one of our trends in the periodic table. Electronegativity is the ability of an atom to attract other electrons. So think of like a singular oxygen atom or sodium atom, the ability for that atom to attract electrons from another atom. Noble gases don't have electronegativities because they already have all the electrons they need to be stable. Those 8 valence electrons, they're already stable, and therefore they don't need to attract any more electrons. Nonmetals, so those elements in the top right of the periodic table, have high electronegativities because they tend to want to gain electrons to have the same number as a noble gas. So if you think of an atom having 6 or 7 valence electrons, like an oxygen or a fluorine, it is easy to gain a couple more to get 8. So they're easily going to attract those electrons to get to 8. Metals have lower electronegativities because it's easier for them to lose their electrons. So think of like a sodium or a potassium. They'll much more easily remove their 1 valence electron than they will gain 7 in order to have the same number as a noble gas. So if an atom has 1 or 3 valence electrons, it's easiest to lose a couple more to get to 8. Here's a visual to look at these electronegativity trends. Fluorine, right here, which is the top right of the periodic table, has the highest electronegativity at 4.0. In general, elements that are closer to fluorine here in the top right of the periodic table have higher electronegativities. And way down here in the bottom left corner, cesium has the lowest electronegativity. In general, elements closest to cesium, or in this bottom left corner, have lower electronegativities. The trend in electronegativity is the same as the trend that we saw in ionization energy, except this trend, electronegativity, you can see here doesn't include the noble gases.